Noon.
Welcome to the second week lecture of Applied Multivariate Statistical Modeling. Today we will discuss normal distribution and chi-square distribution. We introduce and then we talk about sampling distribution followed by Z distribution, then unit normal Z distribution and chi-square distribution. You can recall previous lecture where we started with the basic statistics, particularly the probability distributions were introduced, and I am sure that you will be able to connect with this lecture with the previous lecture. Let us see the best in the coming days.
We will discuss sampling distribution. Sampling distribution. In the last lecture, you have seen that population is characterized by probability distribution with certain parameters. Also, we have discussed that sample can be collected from the population and then estimate of population parameters can be found out in terms of x bar, in terms of s square. X bar and s square, each one is known as statistic, okay, and x bar s square collectively you can say statistics. So, population parameter, sample statistic, they are synonymous. When I talk about population, I talk about population parameters, talk about sample, the sample statistic. Statistic is the estimate of parameter. Okay. Now, if I say that x bar is an estimate of population parameter mu, then what is the distribution of x bar? Similarly, you see that S square is the sample variance for the variable x and it is an estimate of sigma square, that is a population parameter. You may be interested to know the distribution of S square. Getting me? The distribution of a statistic is known as sampling distribution. So, when we talk about sampling distribution, we talk about the distribution of a statistic computed from the sample, that distribution of that. Now, here x bar is a sample statistic. What is the distribution of x bar? Similarly, S square is a sample statistic. What is the distribution of S square? Under sampling distribution, we will discuss these two, but please keep in mind, in general, if we say that theta is equal to, let it be theta 1, theta 2, like suppose theta k, there are k parameters for theta, then definitely suppose your phi is the sample statistic, then corresponding to every population parameter there will be sample statistic will be there. Now, by sampling distribution we say what is the distribution of this statistic, what is the distribution of this statistics, what is the distribution of this statistic. It may be univariate, it may be multivariate. So, if you are interested to know collectively what is the distribution of this statistic vector k cross 1 vector, then it will be multivariate distribution, probability distribution. Essentially, by sampling distribution you are talking about probability distribution only, but the difference is you are talking about the distribution of not the variable characterizing the population, rather the statistic computed from the sample, distribution of that statistic. Clear it is. For example, we have taken the if we consider the same example again, the profit. If you see the 12 months data 1 to 12, so your profit is there, different values of profit. So, you will calculate mean profit, average per month. My question here is, what is the distribution of x bar? Okay. So, with this line, today's discussion is sampling distributions, and you see that there are unit normal distribution, Z stands for unit normal distribution, then chi-square distribution, T distribution, F distribution. These are the most popular, mostly used, widely used distribution for sample statistics. Then we will discuss central limit theorem, finally sampling strategy, because how do you collect the data, it all depends on what strategy you will be adopting, because the data collection process if wrong or faulty, analysis will not give you good result. Okay. So, you may be wondering that where from this, suppose you have collected one sample, for example, you collected the height of people for a particular community, suppose n data points you have collected 1 2 dot 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 n, your value x value is x 1 x 2 dot 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 x n. You are thinking that I have computed x bar here and a square here, and these are all because once you collect data, these are the fixed values. So, your x bar is also a fixed value, a square is also a fixed value for a particular sample. Then where from this distribution is coming? The distribution concept is coming because if you do the same sampling next time, there is no guarantee that you will get the same value of x bar, same value of a square. That is why in statistics, all statistics are, or other way each statistic is a random variable, is a random variable. Statistic is a random variable. In this figure, you see this figure that sample n samples, sample 1 to sample n collected from a particular population, and the sample size is n for all the cases. Sample size means the number of observation collected per sample, and if you compute the mean and variance from each sample, you will be getting for first sample it is x 1 bar and s 1 square, x 2 bar, s 2 square for second sample, like this. And it is obvious that all those values will be may not be same, will be actually it will be different. Suppose if I say that sample 1, sample 2 like sample n, then if you calculate your mean and calculate variance, x 1 bar is the first sample mean, x 2 bar is the second sample mean, like this x n bar is the nth sample mean, s 1 square is the first sample standard variance, and s 2 square is the second sample variance, like this the variance s n square. Now, as these are not same value, what will happen? If you can draw a histogram, How? You can find out the smallest value of x bar. Let it be, if I say x within bracket 1 bar. Originally what happened? Originally you have x 1 bar, x 2 bar, like this, x n bar. If I say this is a vector x bar, which is this one, this T stands for transpose, then you are ordering them from smallest to largest. Then the same thing what will happen, if I say that some order we are giving, then this will be x 1 bar, x 2 bar, x n bar. So, this is the smallest one is this and the largest one is x n bar. So, if you plot, you will get, if you develop a histogram, you may find out a distribution. It may be like this. It may be like this. So, that means what we are trying to say, that if you collect sample one after another from the same population of same size for the same variable, you will get different values for that sample statistic, and that sample, that is why the sample statistic is a random variable, and you have a probability density function for the random variable, and that density function is the sampling distribution function. Okay. Now, you have to know that what are the distribution that comes under sampling distribution. I told you earlier that there are 4 most popular sampling distribution, like Z distribution, chi-square distribution, T distribution and F distribution, and this concept is very vital concept, I am telling you, and very important for later stages when we talk about any multivariate model. For example, multiple regression, there are several beta coefficient. You will be finding out that regression coefficient. These regression coefficient through data, sample data, you will be estimating. They are basically the statistic. So, each parameter will have a distribution. How do I know that what distribution it follows? If you do not understand this, you will face problem there. So, this is I can say that one of the most fundamental concept, and it should be, you should be thorough about this concept. Okay. And now, let us concentrate on what is Z distribution. I am sure that you will not face it a difficult one, because all of you know that this left hand side, the figure, if you see, this is the normal distribution, and the probability density function is f x equal to 1 by, I am writing here once more, f x equal to 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma square, and x varies from minus infinite to plus infinite. Okay. Now, where x is a random variable, this is the original one, original random variable, original one what you have observed, correct. Now, let us transform x in this manner. Let z is a transform variable of x, which is x minus mu by sigma. So, you have observed x, you are creating another variable z, which using x as well as the population parameter like mu and sigma. Then this is what is known as the transfer standardized variable. This is known as standardized variable. So, when a variable is subtracted by its mean and divided, and the resultant quantity is divided by the standard deviation, that is known as standardized variable. So, that means by standardized variable we mean that the variable minus its expected value, that is the mean, divided by that what I can say sigma means basically x minus mu expected value of this square. Square root you give this square root of this, because we are considering standard deviation, square root of this, correct. Now, what will be the mean value of z? 0. How?
Since mean is subtracted.
Every case basically you can write in this manner. Suppose what is mean? Mean is, suppose if I write mean is expected value of variable z. Here we are talking about mean j mu z. So, that means expected value of x minus mu by sigma, that means 1 by sigma expected value of x minus expected value of mu, and c expected value of constant is constant. So, expected value of x is mu minus mu, it equal to 0. So, that is why the z is a random variable whose mean value is 0. What will happen to its standard deviation? You will get 1. In the same fashion, you can find out that what is the standard deviation. Standard deviation means expected value, that is the variance you find out first, variance of z, which is expected value of your z minus expected value of z, that whole square. So, expected value of z already you got 0. So, this basically expected value of z square. So, it is expected value of z is nothing but x minus mu by sigma square. So, if the variance of x, suppose variance of x is sigma square, the variance of a x where a is constant, it will be a square sigma square. So, it will be sigma square. So, that means you can write this 1 by sigma square into expected value of x minus mu square. What is this? Expected value of x minus mu square, that is the sigma square. So, your sigma square by sigma square, this is 1. If this is the case, now you see that in this equation, come back to the slide again, what we have put? We put z equal to x minus mu by sigma square, our resultant equation, that probability density function for z, which is 1 by root over 2 pi sigma square is 1. So, it is 2 pi into 1 means 2 pi square root e to the power 1 by 2 z square. So, this is the conversion of any variable, for example, this normal variable to its unit normal distribution. So, z distribution is also known as unit normal distribution, because its mean value is 0 and standard deviation is 1. Okay. What is the use of why should we convert to unit normal distribution? The reason is even if there are many variables, but once you standardize those any variable, it will be an unit normal. So, you require only one unit normal distribution table, and using that you are able to what I can say use that table to different situation, even though the original variable mean and standard deviation differs. Okay. So, this is our example, and if I consider profit, we are considering the profit, I am showing you that what is the use of standard normal distribution. Here assume the variable profit per month is normally distributed with mean of rupees 11 millions and standard deviation of rupees 1.5 millions. What is the probability that the profit per month will be within 12.5 millions? How do you go about it? You see the left hand side this figure, it is in the original variable, right hand side is the unit normal one. Now, if you see this x axis, the bottom one, you see what is the mean is the middle value, and everywhere that 1 standard deviation, 2 standard, 3 standard deviation, both side the demarcation is there. Now, as sigma equal to 1, that same will be now mean will be 0 and 1 into 1, that will be 1, that is minus 1, minus 2, minus 3, like this. So, this line is what is the z line, because you are interested to know that your probability of profit less than equal to 12.5 rupees million, and if I convert into z value, it is coming 1. So, probability z less than equal to 1, that means this one, this is the z equal to 1, the left hand side values. Probability z less than equal to 1 will be the area under the normal distribution curve from minus infinity to that z value, because we are talking about within this. Now, you have standard normal table. Now, what you will do, once you get the z value, you go for the table. So, our z value is 1, and you see that this shaded portion is the probability, this area is the probability, and whose value is 0.8413. So, you are able to find out the probability that your profit will be within this. Now, second sampling distribution is chi-square. Okay. Do you have any idea that when you will use chi-square distribution? You find out that if you go through the standard book, like very good book, Johnson and Wichen book, you will find that everywhere, maybe when you talk about the constant density contours, there or statistical distance, the chi-square distribution is used. But why chi-square distribution is used instead of t distribution, or instead of z distribution, or instead of f distribution, or any other distribution? What is the basis? That means, we must know that what is chi-square distribution, how it is generated, and where it will be used. Now, you see this slide here, what we are saying, that if z1, z2, zk, what is z? Z is normal distribution, unit normal. So, you have collected suppose k observations, and those k unit that normal observations are that z1, z2, zk, and you are creating one variable which is the sum of the normal variable, unit normal variable square. What I mean to say here, then suppose you have collected in k data points 1, 2, 3 like k, and you have x values for x1, x2, x3, let it be xk, and you know z values, z equal to x minus mu by sigma, assuming that mu and sigma are population parameter, then you are getting z1, z2, z3 like zk. Now, you are making z square, z1 square, z2 square, z3 square, like this zk square. Now, if you take a sum of this zi I equal to 1 to k, you get a quantity. This is also a statistics, because this is the linear sum of the square of the values of the normal unit normal variable. then this quantity, that y, what you have created here y, I have shown here, it is here y, and anyhow you can change it to y, no problem. Okay. So, this quantity follows chi-square distribution with how many degrees of freedom? K degrees of freedom. So, what is the essential learning here? Our learning is, suppose I know that there is a normal variable x, you have collected data on it, you converted it to standard normal, each of the observations is squared and you have taken a sum, and that sum you used for different purposes. That sum will follow certain distribution, that distribution is chi-square distribution. Okay. Remember this one. Suppose usually why normal distribution will start with normal distribution, because normal distribution plenty of things in the real world, most of the things can be converted to normally distributed, that behavior, most of the cases. So, that is the starting point. Now, for the purpose of your analysis, purpose your model building, for the purpose for which you want to use it, there what is required? You require the sum of the square of the variables values. Then what you will do? When you collect one sample, you have to have the distribution of that value, that is chi-square distribution. Any question? Understood fully or not? Sweetie, any question? Okay. And the general form of chi-square distribution is like this, that f y is 1 by 2 to the power gamma k by 2, gamma k by 2, and this is the case, and the mean value of chi-square is the k, which is degrees of freedom, and variance is 2 times degrees of freedom. And this figure you see that this is the probability density function for a chi-square variable. Now, that if x is chi-square, then what is happening here, 1 to 8, these are the values, and ultimately you will be getting different shape of chi-square density function. When your k equal to 1, this is this as well as k equal to 2, it looks like exponential distribution, but slowly that shape will change. So, degrees of freedom plays an important role in chi-square distribution. In Z distribution, what is the degree of freedom required? No degrees of freedom. We have not discussed anything related to degrees of freedom in Z distribution. When the unit normal distribution table you see, there is no degrees of freedom column. So, that means in Z distribution it is basically not affected by the degrees of freedom available with the data set. Chi-square distribution, when you talk about chi-square distribution, please keep in mind degrees of freedom is coming into consideration, and chi-square is nothing but the normal square. My x is normally distributed, I am making the square, linear sum of the square of x, that is my chi-square distribution. So, you may be wondering that where is the use? Now, see, I told you we want to find out the distribution of sample statistic. Getting me? Now, one of the sample statistic is a square variance, yes or no? Very much. What is the distribution of a square? How do we know? What will be the distribution of x bar? See, x bar is 1 by n sum total of xi. X is normally distributed variable. So, x bar, if x is normally distributed, x bar also follow normal distribution. We will create Z by considering x bar minus expected value of x bar by variance of x bar, then unit normal distribution. I will not tell anything related to this computation. Later on I will tell you what is this. From central limit theorem you will know what will be the this distribution. But irrespective of what I mean to say here, that irrespective of the value, that x bar value, if you collect data from a normal distribution, then x bar will be normally distributed. Getting me? Now, what will be the S square? What is S square? S square is 1 by n minus 1 sum total of I equal to 1 to n x I minus x bar square. Can you find out any similarity here? What you have done? I say x is normally distributed, x bar is also normally distributed, difference is also normally distributed. Then you have made the squaring this. So, when normal variable is squared and you take summation and do little bit of manipulation using the population variance, what you will get? You will get standard normal z and summation of square of standard normal z. Is it not correct? You see this this one slide, what we have shown here. A square is just, it is nothing but the formula we have given, x 1 minus x bar square like this, plus x 2 minus x bar square plus x n minus x bar square, and sigma square is divided. This sigma is the population variance. Now, this quantity is coming like z 1 square plus z 2 square plus z n square. So, it is the sum total of normal square, the variable value square. So, it is chi-square distribution. That is why when we will go for interval estimation of variance, we will use chi-square distribution, because it should come to your mind that why x bar, for x bar we are using normal distribution, but for s square we are using chi-square distribution. That means, the crux of the matter is here. This is the development, this is the development. Fantastic. Then you may be wondering that why the n minus 1. Already we have seen that while calculating the s square, 1 degree is lost, then same thing continues, and ultimately our this n minus 1 s square by sigma square, this quantity follows chi-square distribution with n minus 1 degrees of freedom. Okay. Any question for this? So, any question? No question? I think it is obvious now. So, keep in mind this one, because many times you will be using this type of derived units. You will add square and then add, and chi-square is required, but you do not know what distribution you will be using. Just follow this concept and you follow yes chi-square. Some other case it will be other distribution. Okay, this is the use. For example, if we consider the data, then profit variance obtained through the 12-month data, assuming population variance is, you can find out the distribution of the variance component computed from the 12 months data. It is all the uses of this chi-square distribution will be revealed in subsequent lectures, but the concept remain same. When we will use chi-square distribution, this is the concept. Okay. Chi-square table, when you have gone for Z table, please keep in mind that in Z table there is no degrees of freedom column. Chi-square means there will be degrees of freedom. So, the first column itself is degrees of freedom 1 to 15, it will be up to infinite, because chi-square value can go up to that level. Then there are different probability values here, and for different probability values what will be the your chi-square value. So, how to use this table? Any idea? For example, let the chi-square distribution PDF is like this: chi-square this is function of that chi-square mean PDF. Let the distribution look like this. Okay. Now, I want to know what is the chi-square value for the probability of this side, let it be alpha, which is 0. Let it be 0.5. From this table, can you find out this value, chi-square value? What will be this chi-square? 0.05. Understand, because these things you will be requiring later on. You have to see this chi-square table frequently. What I mean to say, I know the probability, right hand side probability here, for which I want to know what will be the chi-square value. If you are giving like this chi-square with probability 0.05, you cannot calculate. You cannot find out the value from here. Which degrees of freedom? Is it 1 degree of freedom or 15 degree of freedom or 120 degrees of freedom? So, that means another quantity should be here, which is known as degree of freedom. So, suppose k equal to 1, then what is this value? K equal to 1, probability is 0.05. So, your chi-square value is 3.841. So, my this value is 3.841. Suppose you require a value where the probability, so what is this? This one is probability that chi-square value is this probability that chi-square value, this value that will be greater than some value. Getting me? So, let any value we are basically k equal to 1, some value, this is 3.8, but that value we will say that chi-square computed value. Getting me? Probability that this is my chi-square is when chi-square is computed this value, this will be greater than this. This is the value, this side, less than this will be other side. Now, if your degree of freedom is 6 and you want the probability that the value is that 9.995, then your value chi-square value will be 0.676, which will be somewhere here. So, you are talking about the total probability this side. Okay.